On Friday, September 20th, 2019, I received a distress call from the vessel Containership.io, reporting that she had run out of fuel, struck debris, and was taking on water. She sent out a Mayday alert asking for assistance in offloading her precious cargo and carrying it to safety. It is my duty to respond. Days like this are no fun. When we as people look at our competitors, it's easy to think that they're the enemy, but they're not. All of us are trying to bring about a change in the world. Containers and Kubernetes are that change, and the true enemy is a world that exists without them. We're all trying to do the same thing. We're all fighting in the same war, and we're all on the same side. So when one of us falls, it's a tragedy. The people at Containership put their hearts and souls into building something beautiful that they believed in, and I have no doubt in my mind that they are utterly devastated to have to close their doors. They didn't do anything wrong. Failure is not something to look down on or avoid. Failure should be celebrated, because it's the only way that we learn what we need to do to succeed. If you are an employee at Containership and you haven't found a new job yet, please send your CV to jobs@rancher.com. There are people there who would love to help you find a new home. You can also reach out to me directly. My contact details are at the end of the video. If you're a customer of Containership, you're probably a little bit concerned that you have to move your stuff out in the next 30 days. You can relax. This video is going to show you exactly what you need to do step by step, and it's not that hard. Containership gave you tools to deploy and manage Kubernetes clusters. You could either import running clusters or you could deploy clusters from their UI. Clusters that were deployed from the UI used the Containership Kubernetes distribution, and those clusters have dependencies baked into them that guarantee that they will stop working after October 31st. There's a point in every story where the hero has learned enough that they can continue on without their mentor. Luke had to do it first when Obi-Wan died, and then again when Yoda told him that he was ready. And now you have to do it. You're ready to become your own Containership, and after following the steps in this video, you will never again find yourself in a place where the sudden collapse of a vendor leaves you wondering if you're going to drown. The key to this solution is Rancher. Rancher is the leading open source solution for Kubernetes management with over 100 million downloads, 30,000 active deployments, and more than 300 enterprise customers. Rancher is 100% free and open source, which means that you don't have to pay anything to do what we're going to do today. If you'd like to talk with someone about an enterprise subscription that includes 24/7 support along with other business value, you can send a request via the Get Pricing button on the support page of the Rancher website. This video is going to walk through the complete process of installing Rancher and moving your clusters from Containership to Rancher. But where something takes a few minutes to complete, I'll speed it up. This is the video that you want to watch if you're pretty comfortable with all of this Kubernetes stuff. If you're a little bit less confident, there will be a series of other videos that have uncompressed timelines in them. The source material is exactly the same, but those videos can be used for detailed reference into exactly what you need to do step by gentle step. The first thing that we're going to do is install Rancher into an HA Kubernetes cluster. This is going to be the master control for all of your Kubernetes clusters. Then we're going to import any Kubernetes clusters that you previously imported into Containership. That's an easy migration. After that, we're going to take any clusters that you launched with Containership and we'll migrate the workloads to new Kubernetes clusters. We'll do that by launching the new clusters with Rancher and then using Velero to back up all of the data and restore it into the new cluster. This is essentially a data center migration, and it's important that when we do this, we change as little as possible. We want clusters that are running the same Kubernetes version, use the same names, are in the same provider, the same everything. The closer aligned those clusters are, the easier the migration will be. After you've done this migration, you can decide if you want to do another migration to elsewhere, but you'll be able to do it when you're not up against a deadline. I'm doing this in AWS because it's the provider I'm most familiar with. You should be able to adapt the information to other providers. But if you'd like me to make a specific video for Azure or Google Cloud, please let me know in the comments below. I'll do my best to help you, but I make no promises. I don't work with Azure or GCP, so it's going to depend on if I can convince one of my friends to work with me on a video that shows how the migration works on those platforms. Before we get started, go into DNS and change the TTL for anything that you're moving. Drop the TTL to 60 seconds so that when you change DNS at the end of this video, your traffic changes over to the new cluster almost immediately. If your TTL is currently set to something large like 24 hours, you'll have to wait that long for the change to propagate before you begin the migration. I suggest that you watch this video all the way through before you do any of these things so that you know exactly what you'll be doing and you won't be trying to figure something out on the fly. Make a plan for the migration and then execute the plan. Look at every phase of the plan and ask how it applies to your environment. Ask how each step might fail, and be prepared with a rollback plan if something goes wrong. Unfortunately, all the way to the end, the rollback plan is either stop the migration or point DNS back to the original cluster. There's really no risk of anything going wrong. Create a security group called Rancher Server in AWS. Grant inbound access from anywhere on the following ports: 22, 80, 443, 6443, and TCP and UDP for a range between 30,000 and 32767. Save the group so that it gets assigned an ID, and then open it up again. Grant the group all access to itself and save it again. Next, we're going to create a launch template that we'll use for our Rancher cluster. This step isn't required, but it makes it easy to launch a standard set of servers. I'm going to use Ubuntu 18.04 as my base image. The instance type will be t2.large because Rancher and Kubernetes will breathe easier with 8 GB of RAM. Choose a key pair, and if you don't have a key pair in AWS yet, you can jump out to the EC2 overview in another tab, create one, and then come back into here and click the refresh button to reload the options. You should see your new key pair, and then you can select it. Make sure you have the private key for this key pair. Choose your security group. When I did this for the video today, Amazon was having a weird issue where they were adding a second group and then erroring out when launching instances from the template. This wasn't happening yesterday, and it was happening today, so it sounds like a bug to me. If you see it, it'd be a second group with the same ID. Delete the one with the name. If you don't see it, then there's nothing to see here. Move along. Don't set a network interface, it'll get the default when launched. At a new volume of 16 or 20 gigabytes, it really doesn't matter. 16 is enough, but I find 20 to be a more pleasant number. Under advanced settings, add a user data block to automatically upgrade the system and install Docker. You can copy and paste that from this link here. Click Create Launch Template to save it. Next, choose Launch Instance from Template. Select your template version, and then you have to make a decision. If you want to launch nodes in different availability zones, you'll have to launch one instance selecting a different AZ each time. Personally, I think the need to spread systems out across AZs is somewhat overrated. There's a chance that an AZ could fail, but it happens relatively infrequently, like maybe once every couple of years. Meanwhile, you will pay Amazon every single month for inter-AZ traffic, and with a chatty solution like Kubernetes, it's very likely that you'll pay more for protection against an unlikely event than what you would have to pay to relaunch your nodes and restore a backup if an AZ actually failed. Usually I just tell it to launch 3 nodes in one AZ because I'm comfortable with that level of risk. If you aren't comfortable with this, then I recommend you tell it to launch 1 node, then select 1 subnet. Then come back, repeat with another node in another subnet, and finally a 3rd node in the 3rd subnet. This will guarantee that your nodes are spread out across the AZs. Now, let's fast forward to the next step. Once the nodes are up, edit them to give each a name, like Rancher 01 to Rancher 03. Now we're ready to install RKE. Grab the latest copy from the releases page and put it somewhere on your local machine. RKE runs from your workstation and configures systems out in the internet. Make a directory to store the configuration, and from that directory run RKE config. You can accept the defaults for pretty much everything, but use the internal and external IP addresses for each host when asked. I also like to override the node names with their friendly names, like Rancher 01 to Rancher 03. That makes it easier to know which is which when viewing them in Kubernetes. Make sure that each node has all 3 roles: control plane, etcd, and worker. With this done, run RKE up. If you've done everything correctly up to this point, you won't have any errors. RKE takes a few minutes to install, so while that happens, we'll drop a network load balancer in front of the nodes. This will map ports 80 and 443 to our Rancher server, and that'll give us a single point of entry to the HA Rancher deployment. Create a target group called TCP80. Set it to TCP on port 80 and save. Select the Targets tab, click Edit, select your 3 RKE instances. Make sure that it says on port 80 next to the Add to Registered button and click the button. Click Save. Do that again for a group called TCP443, mapping to the same instances on port 443. Next, select load balancers and create a new load balancer. Choose Network Load Balancer. Give it a name like Rancher Server. It will have 1 listener enabled by default for port 80. Add a second one for port 443. Select all availability zones and click Next. The next screen will be empty. Ignore the warning, click Next. Choose Existing Target Group and select your port 80 group. Don't worry that you can't add a second target group right now. Just click Next. The next screen shows you your targets. Click Next and then click Create. Select your NLB in the list, and in the bottom of the screen, select the Listeners tab. Click the checkbox next to your port 443 listener, click Edit, and click the trash next to the Forward to TCP 80. Then click Add Action and choose Forward to. Select your port 443 listener and click Update. Click the little back arrow to come back to the load balancer screen, and now you should see that 80 goes to 80 and 443 goes to 443. Click the Description tab and copy the DNS name for the load balancer. Save this in your notes somewhere. Now, let's fast forward to the next step. At this point, you have an RKE cluster with a load balancer in front of it. RKE has left you with a configuration file called kubeconfig-cluster.yaml, which we'll use for the next step. I normally use a shell called fish, but the default shell on most systems is bash. For this demo, I'll use bash so that you can copy the commands exactly. If you don't have kube control on your local machine, go to this URL to get it before continuing with this video. Similarly, if you don't have Helm installed on your local machine, you can go to this URL to get that. You'll need both of them in the next step. Point your kubeconfig variable at the config file, and if you run kubecontrol get nodes, you should see output. Next, we're going to install Rancher using Let's Encrypt to generate the TLS certificates. Pick a name for your new Rancher server. I'll use rancher.productionwebsite.com. If you have your domain in Route 53, you can create an alias to the load balancer that you created earlier. If you don't use Route 53, or if your DNS zone is under a different account, like mine is, you'll have to create a CNAME that points to the host name for the new load balancer. After this is done, wait a few minutes for it to propagate, and then do a DNS lookup and an HTTP query to make sure that you're landing on the right place. You should get a 404, and that's fine. When doing the DNS query, I recommend that you query public name servers like 8.8.8.8 or 1.1.1.1. The default action of most local name servers is to cache a DNS failure for 2 hours, which means that if you query your local name server just before the record propagates, you might be stuck for 2 hours before the record shows up. By querying public name servers, you can avoid the risk of caching the NX domain response. Next, we're going to initialize Helm, which is a copy-paste command. This will install Tiller into the cluster, and we'll use that to deploy Rancher. Next, we add the stable repo and run helm repo update. This makes sure that we have the latest chart information for the repository. If for some reason you want to use self-signed certs or your own cert from a real CA, the docs page shows the various options and explains how to use them. Honestly though, there's no reason not to use Let's Encrypt for this. For that, we install Cert Manager from Jetstack. Jetstack development moves very quickly, so I prefer to follow the instructions on their site. We first install the CRDs, and then we create and label a namespace for Cert Manager. We follow this with adding their repository to Helm, running helm repo update again, and then we're ready to install Cert Manager. Because of the speed at which Cert Manager development happens, always specify a version to install. At the time of this video, the latest stable version is 0.10.0, so that's what we're going to install. We'll check the Cert Manager namespace and wait for the pods to come up before continuing with the Rancher install. Installing Rancher is also just an easy copy-paste. We just have to tell it our server hostname and also tell Let's Encrypt who the contact email is for the certificate that it generates. While that rolls out, let's review what we've done so far. At this point, you've just created something that can do everything that you were doing with Containership and more. And you've built it in an environment that you control on hardware that you manage. Congratulations are in order, but there's still more work to do. All we've done at this point is get you off Containership. Now we have to get your clusters off too. Finish off the Rancher installation by going to the server URL in a browser, setting an admin password, and verifying the server URL. The server URL is important. It should be the hostname that you use to connect, because that's what downstream clusters are also going to use to connect. It needs to be accessible from those clusters, so you can't, for example, run Rancher in your office and then expect to use it with Kubernetes clusters out at AWS, unless those clusters can somehow reach the Rancher server by hostname. The view that you're taken to is the clusters view. Now, I'm not going to give you a full overview of Rancher in this video. For that, you can join the weekly Intro to Kubernetes and Rancher training that JVB and I do for Rancher every Thursday. After setting the server URL, you can wait for the cluster to change to active, or if you're impatient like me, just click Edit and then click Save to force it to pick up the change. Let's move on to migrating your clusters, starting with the imported ones. If you launched clusters and then attached them to Containership, we can very quickly move those to Rancher. When you imported the cluster, you provided Containership with a kubeconfig file. Find it, and in a different shell window, point the kubeconfig environment variable at it. Verify that you're pointed at the right cluster by running kubectl get nodes or kubectl get pods. We're going to first import that cluster into Rancher, which we'll do by clicking Add Cluster and then Import. Give it a name, which should probably be the same name you gave it in Containership, just to keep things easy. Click Create, and then copy the kubectl apply command that you're shown. If you created your Rancher server with Let's Encrypt certificates or a certificate from a real CA, you can use the middle command. If you're using self-signed certs or certs from an internal CA, then you'll have to use the last command to bypass complaints about certificates that are signed by an unknown authority. Run that command against your cluster, and you should see it join the Rancher server. Wait a few minutes for it to turn green. Actually, it might only take a few seconds. And when that happens, it means that Rancher can control the cluster. You can select it, you can look at workloads or other things, and you'll see that Rancher has imported everything about your cluster. I've talked about projects a couple of times already. When you import a cluster into Rancher, anything in the default namespace is put into the default project, but Rancher doesn't know what to do with other namespaces. So from the cluster overview page, go to Projects Namespaces and take each of those namespaces that are listed as being in all and move them into a project. You can either move them into the default project, or you can create a new project and move them into that. When you're ready to continue, delete the cluster from Containership. Now, according to Containership, this will delete the Containership core namespace and everything running within it. My experience, as you'll see here, is that it does not. We want to first come up to namespaces, and we'll see that the namespace is still here. We can tell Rancher to delete it, but it's going to stay in a terminating state because deleting the namespace doesn't delete all of the API resources that Containership installed. The namespace will stall forever until we delete those manually. They don't show up if you run kubectl get all, but they're API resources for authorization roles and authorization role bindings. We can't just delete these either. We have to remove their finalizer entry before they'll actually delete. But once they're gone, the namespace will finish deleting on its own. So to do that, there's a command at the link below that you can run against the cluster. This will iterate and clear the finalizer on each of the stuck resources. The namespace will delete after that, and this cluster will be freed from Containership. Repeat this whole thing with any other imported clusters, and then let's move to the clusters that you launched from within the Containership UI. Before we start, let me explain what we're running. I have a simple cluster that I launched from within Containership. It contains two namespaces, one running MariaDB that I installed from Helm, and the other running WordPress. There are services and an ingress, and there's a DNS record that points farewell.cs.minoc.us to this cluster. This covers a broad swath of what you might be running in Kubernetes: Helm charts, multiple namespaces, ingresses, databases with persistent volumes, storage classes, and more. But it doesn't cover everything. It's up to you to determine what's running in your cluster and adjust these steps as necessary to move it. We're going to install Velero and configure it to run a backup of our workloads to S3. We're only going to back up workload namespaces, not the whole cluster. There are things running in the Containership cluster that we don't want to move. This process is complex, and it took me several iterations to figure out the combination of steps that will work for you. Please follow along carefully, but take your time, move slowly, and don't do the final cutover until you know that things are ready. Velero is a tool for backing up and restoring Kubernetes clusters. It's from Heptio, who are now part of VMware, and for what it does, it's good. It's not perfect, but it's also the only thing out there, so I'm not really going to complain. The docs for Velero are a little bit sparse, but they have install information for the major cloud providers. Like RKE, Velero runs locally on your workstation, so first download it and install it. If you aren't set up to run the AWS command line utilities locally, there's a link on the Velero install page, or right here, for where to go to set that up. Go take care of that, and then come back here when you have it up and running. If you want, you can copy and paste the commands from the Velero install page, but if you do that, you'll have to change their commands. They're using variables for bucket and region, but the way they have their commands written, these will only have values in the first command. This doc looks to have been written by chopping up a single script, and if you just copy and paste the commands, you'll end up with something that has empty variables, and nothing will work. To get around this, you can either use export with the two variables at the beginning, or you can go to this URL here and use my script instead. If you use my script, then skip the next part where I talk about the bucket and IAM policy parts, and then start again with the part where we create an access key. We're going to use the AWS CLI to create an S3 bucket. This doesn't have to be the bucket that you use forever. We're only going to use it for this migration, so the name probably doesn't matter. Put the bucket in the same region where your cluster is running, because that's also the region where we're going to launch its new twin. Once you have the bucket created, create an IAM user for Velero and attach a policy to it that allows it to interact with AWS resources for making backups. Create an AWS access key for the Velero user. Save this information in your notes because you'll never get to see it again. Create the file credentials-velero in the current directory, populating it with the access key and secret key from the output above. You're now ready to install Velero. Include --use restic with the install command. We want to install restic because that's what's going to back up and restore persistent volume data. This takes a few minutes to complete, so I'll talk about the next step. Restic requires that you annotate the pods whose data you want backed up, but if we're running pods from a deployment, we don't want to annotate them individually. When they are eventually recreated, those annotations disappear. The obvious answer is to annotate the deployment, but then all of the pods are annotated. I didn't experiment with restic to see if it's smart enough to only back up the data once. I hope that it is, but that's a story for another video. For today, we just want to get a backup that we can use to move the cluster. So we're going to annotate the pods that have persistent volumes that we want to migrate. In our case, that's the WordPress pod and the MariaDB pod. Doing it this way means that when we restore to the new cluster, the pods won't automatically get annotated, and then we can decide if and how we want to run Velero over there. Go through your infrastructure now and make the same annotation for everything that has a volume you want to back up. The label is backup.velero.io/backup-volumes equals a comma-separated list of volume names from within the manifest. For my WordPress pod, that's called HTML shared. For my MariaDB pod, that's called data. I don't want to back up every namespace in the cluster. Like I said, there are things in kube-system that I don't want to install again, and then there's the whole Containership core namespace that we also don't want to move. What we do want to back up is any namespace that has production workloads. We also want to separately back up the config maps for any Helm charts that we deployed into the cluster. I have the default and DB namespaces, and I'm going to back them up now with this command. Velero returns almost immediately with a subsequent command that I can run to monitor the status of the backup. We want to wait until that command returns with no errors, and make sure that the restic backup section shows that the persistent volumes were also backed up. You can provide --details to the describe commands to get more information about everything that it backed up. When you're done with that, run another backup on kube-system using a label selector of owner equals tiller and status equals deployed. We only want to grab the config maps, so even if it grabs something for a workload that you're not going to redeploy, that's fine. We can remove the config map for those resources afterward. At this point, you have a backup of your cluster in S3, and you're ready to build a new cluster and restore the backup into it. We want Kubernetes to dynamically provision resources like EBS volumes and load balancers for our workloads. Before it can do that, we have to tell AWS that it's allowed to, and the way that we do that is with an instance profile on the nodes where the new cluster is running. That profile gives the nodes permission to provision resources, and since Kubernetes is running on the nodes, Amazon does what it asks. So from the IAM dashboard, select Roles and then Create Role. Select EC2 as the service that will use the role and click Next. Skip all the rest of the stuff and keep clicking Next until the review page and give it a name like Role Rancher RKE Host. Click Create Role. In the next screen, select the role again, and under Permissions, select Add Inline Policy. Click the JSON tab and paste this policy into the window, replacing what's there. Click Next and give it a name like Rancher RKE Host, and then save. Write down the name that you chose for this role, as you'll need to know it when you launch a cluster later. Best practices for AWS dictate that you never log in as the root account. You use that account to create an IAM account with the admin privileges, and then you use that account to create specific accounts to do specific things. If you don't have an IAM user account, go back to the AWS console, click IAM, click Users, and create an account for yourself. Since you launched the Containership clusters once before, though, I'm going to guess that you already have an IAM account, and we'll use that for the next part. Let's go back to our Rancher server. In the top right corner, click your avatar image and select Cloud Credentials. Click Add Cloud Credential, and in the screen that opens, give it a name, select Amazon, and enter your IAM access key and secret key. Select the region where we'll be deploying the cluster, which should be the same region where your current cluster is running and where you just made the backup to S3. When you're ready, click Create. Next, from the same API menu, create node templates for the nodes that you want to create and the AZs in which you want them. If this is a fault-tolerant cluster, the most fault-tolerant you can be is to have 3 etcd nodes, 1 in each AZ, 2 control plane nodes in different AZs, and workers wherever you need them. That's a production configuration. If you want to be less fault-tolerant, you can combine etcd and control plane nodes, and if you want to be even less fault-tolerant than that, you can stick everything in one AZ or even go so far as to stick it all in the same nodes. But that's crazy talk. Let's assume that you're serious about this, so you're going to distribute everything across 3 AZs and 3 different planes. Create an EC2 node template for 1 AZ in your region. We're in US East 2, so after telling it to use my cloud credentials, I'll start with US East 2A. I select the subnet for that AZ and then select a security group. It's best to tell Rancher to create the security group for you because it knows what you need for a default cluster. Under the instance options screen, choose an image size appropriate for your cluster. I'll choose T2 large and an Ubuntu AMI for US East 2. If you don't know what AMI to use, go back to the AWS console and under the EC2 dashboard, click Launch Instance. Scroll down to the AMI that you want to launch and then copy the AMI ID from the top line. If you're not using an Ubuntu AMI, change the SSH user to the right user for that flavor of Linux. Set the instance profile name you created earlier and scroll down to the Rancher template section. I like to use an abbreviation like UE2A-large, which tells me that this will launch a large instance in US East 2A. You can also click Add a Description and put in additional data that will help you remember what parameters are in this template. Click Save. On the right side of the line with your instance template, click the hamburger menu and choose Clone. Keep all of the settings except for the AZ and the subnet, and then change the name to reflect that it's in a different AZ. Do it again with the third AZ. If you plan to launch control plane or worker nodes on different size instances, repeat that whole process for each AZ and change the instance size, so you have 2 templates for each AZ, each with a different size instance. Some people, for example, want larger nodes for the workers, so it makes sense to have an XL or 2XL template for each AZ. I realized after setting up the node templates that they had a default disk size of 16 gigs. That might be fine, but it feels a little small. Every workload that we're going to attach will use an external volume of some sort, but 16 gigs is cutting it a little bit short for normal host-bound things like container images, logs, and other stuff. So I'm going to go back and change them all to 50 gigs. Now we're going to launch a new cluster into EC2. Rancher will provision the nodes, install Docker, install Kubernetes, and then wire them back into the Rancher server for management. You're probably over there asking, hey Adrian, why aren't we using EKS? I thought about it. It's a great solution, albeit one that costs an extra 20 cents an hour for the control plane. But we're not going to use it because it only supports Kubernetes up to 1.13. Since it's possible that you have Containership clusters running on 1.14 or even 1.15, I want to show you how to migrate to a solution that uses the same version. From the main cluster view, select Add Cluster. Choose Amazon EC2. Give it a name, and let's start building out the node pools. Containership gives you masters and workers. You could keep the same format, building out the same number of masters and workers here, and making them the same size. But like I said above, that's not actually the most fault tolerant that you can be. A Containership master is a node that runs etcd and the control plane, but we're going to separate them into two different groups. I'll say again that you don't have to execute this level of fault tolerance if you're not ready for it, or if you don't want to pay for it. It's up to you. As long as you have 3 etcd nodes and at least 2 control plane nodes, you have an HA cluster, even if all of those are running in the same AZ. You decide what your risk tolerance is and how that compares to your budget. The name that you put into the name prefix box will have a number appended to it. If you're launching everything in one AZ, it makes sense to use something like master in that box because you'll end up with master 1 and master 2 and master 3. But if you're launching one node in each AZ, you'll end up with 3 nodes named master 1. That's not helpful at all. So if you're launching in multiple AZs, make each name unique. You can have master-a- and master-b-, which will turn into master-a-1 and master-b-1 and so on. Select your version of Kubernetes, which hopefully isn't 1.15. I didn't see that Containership gave you a choice for network provider, so you can keep the default of Canal. Canal gives you the easy networking of Flannel, but it brings over network policy support from Calico. It's a good middle-of-the-road network provider. Select Amazon as your cloud provider and click Create. Now, go get a coffee or take a walk or something. Over the next 10 minutes or so, Rancher's going to provision your nodes and wire them all together, installing Docker, Kubernetes, and then connecting them back to the Rancher server. When it's all done and ready, you'll see the cluster change to active, and you can proceed with the next step. Meanwhile, those of us who are trapped in the YouTube window will just speed up time again so that we can keep going. All right. Once you see worker nodes appear in EC2, even if they aren't finished with the install yet, create a new network load balancer that maps 80 and 443 to the worker nodes. The cluster will be running the Nginx ingress controller listening on all worker nodes, so you'll need a load balancer in front of it for your workloads. If you use any other ports besides 80 and 443, create listeners and target groups for those as well, and be sure to register the load balancer in any subnet where you have workers. For us, in this example, that's all 3 AZs. Now, this is exactly the same as what we did before, so I'm just going to zip through it. Inside of Rancher, select your cluster. Even though the cluster is active, that just means that the Kubernetes API is ready. Rancher needs another few minutes to bring up the worker nodes, so wait until it says that all nodes are ready before continuing. Rancher divides your cluster into projects, and projects are a logical collection of namespaces that you can use to easily assign role-based access control to cluster resources. There are 2 projects created for you. The system project has all of the Kubernetes system stuff that you probably shouldn't be playing with, and then the default project holds the default namespace to start. If you were using the EBS storage class to dynamically provision volumes in your Containership cluster, you'll need to create that here. Containership called it EBS-SC, so we need to use the same name. From the cluster overview screen, click Storage and then click Storage Classes. Click Add Class, and in the screen that opens, give it the name of EBS-SC in all lowercase. GP2 disks are automatically selected, which should be fine. If you know that you need other storage classes with other disks, then you already know how to create them. If you drop down advanced options, you can change the reclaim policy. This is set to delete by default, but if you want to manually clean up volumes, you can set it to retain. Click Save to create the storage class. Click the cluster menu to come back to the overview screen. In the top right are two buttons. You can run kubectl commands directly in the shell that opens if you click the Launch kubectl button, and next to it is the kubectl file button. If you click that, you'll be shown a kubectl file that you can copy down to your local machine. Copy it down to your local machine and point your kubectl variable at it. Run kubectl get nodes to make sure that you're pointed at the right cluster. If you used Helm to install anything in your Containership cluster, you want to install Tiller into this new cluster. The steps to do so are the same ones that we used with the Rancher server install, but you can get the command from this URL. Next, we want to run our Velero install command from the same location that we ran it last time so that it can use the credentials that we created. You don't have to do the whole thing, just the install part, which you can find at this URL. Once Velero is installed, it will be pointing to the same location as your other cluster, and you can see this in the output of Velero backup get. The Velero docs for cluster migration suggests that we make this backup location read-only, but as long as we don't do anything to intentionally delete these backups, there's no real risk if we just leave it alone. By leaving it alone, we can continue to use this backup destination after we complete the migration. Okay, you're doing great. I know that this is a lot of stuff you probably didn't sign up for. The good news is that you're almost done, and all of this counts toward valuable knowledge. I mean, come on. How awesome is it going to be when you go to your boss and say that you moved off of Containership with no downtime within days of them announcing that they were shutting down? People are totally going to buy you beers. So, let's wrap it up. We're going to restore our backup, which is easy. But before we do this, listen to this next part. When the restore finishes, there's a chance that you'll see everything in a pending state. If you look at the workloads, you'll see that they're waiting for storage, and if you look at the PVCs, you'll see that they're stuck in a pending state because they can't find the node where they used to be running. What? Yeah, so if this happens, you'll have to edit the PVC and look for the annotation for kubernetes.io/selected node. Delete it and save, and this will let the process continue. If you're doing a large restore of multiple namespaces, you would need to fix all of these volumes before the restore times out, and that might not be possible. So if you're at all concerned about having to manually correct a whole mess of PVCs, do the restore one namespace at a time, or one namespace and one workload at a time, whatever you need to do to not be rushed through that fix. You can do this by passing -- include namespaces or -- include resources. You can see all of the options if you run Velero restore create -h in your terminal. Okay, so we'll do the restore now, and you'll see how it works. Since my restore is small, I'm going to just restore it all and then manually fix the PVC entries. The restore command is easy. It's just Velero restore create -- from backup and the backup name. Like the backup, it'll give you a command that you can run to monitor the status, but you'll need to watch the workloads and PVCs to see if they need you to come in with a crowbar. Okay, this part was unexpected, but it gave me a good opportunity to demonstrate some troubleshooting. After cleaning up the PVC, it bound, but the pod still wouldn't start. I dug into it further and discovered that the volume had been created in US East 2C, and I only had worker nodes in 2A and 2B. Had the volume been created as part of the launch of the workload, both the volume and the pod that requested it would have been in the same location. Instead, the volume was created as part of the restore process, and the pod was created to use it. Now we're stuck with a restored volume in one AZ and no workers who can talk to it. This is another reason that I don't like multi-AZ deployments. When dealing with persistent storage, your storage is bound to the AZ where it launched. That means that this workload, my master database server, can never move from the AZ where its volume lives. And that means that having workers in multiple AZs buys me nothing. It just costs me more money. And I'm not talking about a trivial amount of money. I'm talking about significant money every single month for a fault-tolerant solution that isn't even fault-tolerant. So consider that when deciding how to architect your cluster. For now, the fastest way for me to bring this online is to launch another worker in US East 2C, and after doing that, the pod schedules to that worker and the database comes up. After the restore completes, or after you finish all of the restores that you're doing, we'll do a restore of the tiller config maps. You can see right now that there's no response to Helm list. The config maps that tiller needs are in a different backup, so we'll just do the restore from that backup to put them into place. Just like last time, Velero will give you a command to run to watch the restore status, and once it's done, if we do Helm list, we see the chart status again. Sweet. My source cluster had the Nginx ingress controller installed via Helm. The new cluster has it already installed by Rancher, so the config map for the Nginx ingress controller is no longer needed. I don't know if having it there will cause an issue, but I prefer to delete it just to be sure. Things that don't exist can't cause issues. Back in Rancher from the cluster overview screen, click on Projects Namespaces, and you'll see namespaces that you imported into Rancher. Select each of those and then click Move, and select a project into which you want them to go. You can put them all in the default project, that's fine, or you can create other projects and then move different namespaces into those. Do a spot check through everything. Make sure your pods are up and running, make sure that services are correct, and that ingresses are working. Add an entry in etc hosts on your machine that points to any HTTP host name and one of the IPs of the new load balancer, and then hit the sites in a browser. When we do that, we can see that our WordPress site is up, which means that we're ready to complete the migration. To do that, we just have to change DNS and wait for it to propagate. If you dropped your TTL to 60 seconds earlier in this video, that will happen quickly, and you'll be able to see in the logs or usage metrics that people are on the new cluster. There's one thing about this whole process that makes me uncomfortable, and that's how Restic does their backups. We're backing up the database. How do we know that backup is secure for a particular point in time? I don't think we do. And if there's a chance of data corruption, then we need a better way. Because Velero only supports Restic, there isn't a better way to do this migration. Instead, here's what I suggest you do. First, run the migration exactly as we just did it, but don't repoint DNS. This will recreate all of your workloads and the volumes, so the structure is there. It'll even load the data that it last backed up, which will be enough for you to test. Then, schedule downtime for your Containership cluster, during which you'll do the final migration. Put up a maintenance page on your site so that the data isn't changing, and either run another backup and restore of just the database resource and volume, or else dump the database from the Containership cluster and then restore it into the new cluster. Do another test against the new cluster and then repoint DNS. Traffic will fail over to the new site. If you want to keep doing live backups, there's another solution called Stash that's built around Restic, and it looks like a better cloud-native solution for point-in-time backups. I didn't use it for this video because it's much more complex to set up, and because Velero has specific guides for doing cluster migrations. You have until October 31st to do this migration. Please do it as soon as possible. When you do it early, you can keep your Containership cluster online with the data intact in case there's an unforeseen issue with the new cluster. There shouldn't be, but stuff happens. Keep monitoring the new infrastructure and feel good because you're in control of your entire environment now. Learn about the other things that Rancher gives you, like monitoring, alerting, CI/CD integration, integration with backend identity providers, and so much more. If you need help, go to slack.rancher.io to get an invitation to the Rancher users Slack channel, and there's an entire community waiting there to help you succeed. If this video helped you, please give it a thumbs up and subscribe to the channel. I put out new videos every week, and if there's something that you'd like to know more about, you can make a request on Twitter or in the comments below, and I'll see about getting it into the queue. If you know anyone else on Containership, please share this video with them so that they can migrate safely too. Let me know in the comments below how your migration goes, and welcome to the Rancher family.